Let's take another look at our system diagram of an instrumentation model. So we have the measure end, or the physical quantity that we're measuring, and that's measured by the sensor. The sensor sends an unconditioned signal, usually a voltage, resistance, or current, to the signal conditioning area. Now this is what we want to focus on. So signal conditioning just really means modifying the signal. So 4 common ways that we might modify a signal are amplification, or amplifying a signal, analog to digital, which we touched on a little bit already. This converts an analog signal from a real-world signal into a digital signal, which can be stored and utilized by a computer. We might filter a signal, which means we're getting rid of the unwanted frequencies. We also might isolate a signal, which means that we're physically separating the circuit, which will still allow this signal to transfer. For example, we might use a transformer or an optical isolator. We aren't going too in-depth into signal conditioning because you'll learn more about these types of devices in other classes. For example, amplification and filters, you'll learn about in electronics. Analog to digital devices, you'll learn about in digital logic. But calibration is the thing we want to focus on here. Sometimes the signal's calibrated before it reaches the controller. Sometimes we calibrate the signal in the controller. It depends on the system. We'll talk about what calibrating a signal is next.